Hi guys. So today we will just go through build and optimize data warehouses with BigQuery. So this is a lab. Let me show you the path for a data engineering learning path. So yep. So if you really as of now I'm preparing for a professional data engineering certification. So this is the path which you need to go, like data engineering learning path. So here you have a few courses and labs as well in order to get understanding on the certification, and also in order to understand data engineering using Google Cloud. So let me just go through what I have learned. So I'm not go in detail, but I will just go through the topics, like, so as of now, let me just show you. So yeah. So these are the seven steps. Not I cannot say steps, but so these are the courses which Google has provided in their data engineering path. So I've just noted down here. So as of now, I have completed one, two. One, two, three, four, five. So preparing for Google Cloud Professional Data Engineering exam, and this is the estimated time which they have provided in their course. And this is second part is Google Cloud Big Data and Machine Learning Fundamentals. Third is modernizing data lakes and data warehouses with Google Cloud. Fourth, serverless data processing with data flow. So these are data flow, and this is a GCP service. So in these courses, you will get to know all the Google Cloud services, which are a key part in data engineering aspect. So the fifth, I have also completed fifth one, like perform foundational data, ML and AI task in Google Cloud. So this is a lab. So today I'm just trying to learn by going through this lab session, that is build and optimize data warehouses with BigQuery. So I thought to create a video on this while I learn. Ignore my, I don't have much communication skills. So just ignore my communication skills, guys. So I'll just try to improve it further. So today I will just go through this lab session, or with regards to BigQuery. So this is a data warehousing service in Google Cloud. Let's okay, I have already opened this. So as we can see, it might take 7 hours. Let's see why does it take 7 hours. So first lab is it is taking 30 minutes, and this is second lab. So these are just the lab sessions which are, uh, by clicking on this, you will have a special access to Google Cloud with some certain credentials which are created by Google, and we can use those credentials to in order to complete this lab sessions. So after we complete it, and I think you will complete this. You will get this as a skill badge in your profile. So I think this is 10 credits. Okay, let's just start. Yeah, we will just go through this first one. So as you can see, on the left hand side, there is a start lab session. So whenever I click this start lab, it will just provide me with a unique, a special access to Google Cloud certification. Sorry, this special access to Google Cloud, and I can use those credentials. Then I can, log in, and I can able to do whatever I want with this session. I hope I don't think so people can access this specific Google Cloud as well, but I'm not sure. Let's just hope, yeah, it won't be accessible to other people. Yeah. Yeah. So this is let's just go through this. Oh, already it has been started 30 minutes. So yeah. So BigQuery command line. Okay. So before going on to this, in my previous courses, I had some introduction to BigQuery and what does it do and how can we ingest data into BigQuery. And I had just some theoretical concepts and some few labs, but this is entirely on BigQueries. So on So I have to go through, I mean, whatever they are putting up here, and I have to go understand them and try to do it. I will just go through this overview. Storing and querying massive datasets can be time consuming and expensive without right hardware and infrastructure. So BigQuery is a serverless, highly scalable cloud data warehouse that solves this problem by enabling super fast SQL queries using processing power of a Google infrastructure. Simply move your data into BigQuery and let us handle the hard work. You can control access to both the project and your data based on your business needs, such as giving others the ability to view or query your data. You can access BigQuery by using a console, web UI, or a command line tool. So, using a variety of client libraries such as Java, .NET, or Python. There are also a variety of solution providers that you can use to interact with BigQuery. So, this hands-on lab shows you, sorry, shows you how to use BQ, the Python-based command line tool for BigQuery, to query public tables and load sample data into BigQuery. So this is the setup and requirements, guys. I think I have gone through this several times. So I have to just click on this start lab, and they will provide the username and the password, and this is a project ID. So and how to start your lab and sign in into the Google Cloud Console. So this is yeah. So let me just show you. Yeah, you have to go through the incognito. Yep. Yeah, it will automatically fill in this user ID, I mean username, and I have to just copy. Yep. Yes, now I can able to. Yes. Now we have access to this specific Google Cloud, I mean project as well. Now let's just go through this. So activate a Cloud Shell. This I have done in previous session, so I will just show you like. So click on this activate Cloud Shell, and click on continue. So this is just like accessing the Google Cloud using terminal. So that's the Cloud Shell concept. So here it is just an optional, but we can so using this command we can just check this thing. So you have to provide authorize. Yeah. So you can see this is an account. Yeah, and yeah, this command will give you the project list. So as of now we are focused on this specific project. Okay, then what else? Config list. Okay, this is done. So coming to the task one, we have only 25 minutes to complete entire lab, and as you can see we have 7 tasks to do. Let's hope it will be done in under 25 minutes. So let's see. So task 1, examine a table. BigQuery offers a number of sample tables that you can run queries against. In this lab you will run queries against Shakespeare's table, which contains an entry for every word in every play. Okay, so we have a Shakespeare table, okay, which contains an entry for every word in every play. Okay, so to examine the schema of Shakespeare's table in the samples data set, run this. Okay, so okay, so I think I didn't give you a brief introduction like of these labs, because in each lab they would have certain task we have to do. They will provide most of the scenario, like how to do it and what's the expected output. So I mean it's a really good useful lab sessions. So that's the thing I want to say. But yeah, we'll just continue with the task. So let's click on yep. So yeah, so now using this command what did I find? Okay, so I found out the schema of the Shakespeare table. Yeah, so schema is nothing but a metadata. So metadata in the sense a data about a data. So when I talk about schema, it's like data about but a specific table. I guess I'm guessing it's only related to a table. Yeah. So in this command, you are doing the following: bq to bq in the, I mean, short form for BigQuery. So to invoke the BigQuery command line tool, show is the action. Okay. Then you are listing the name of the project. Okay, this is a sorry, what is this? The public data set, okay, or the project, I'm not sure. Yeah, and samples and dot Shakespeare, okay, in BigQuery that you want to see. Okay, this is the output. Yeah, I think we have got this output as well. Okay, this we have done. So now let's just check, and you can check this progress. Like, this is our first task, right? So we can check this, but run a query. Okay, I think this is not the task one. Okay, examine. Okay, let's hope. Yeah, run the help command. Okay, bq help query. Okay, this we have done. So when you include a command name with the help commands, you get the information about that specific command. For example, the following call to bq help retrieves information about query command. Okay, got it. So run a query. I guess this is what it was described here. Okay, run a query. Okay, after doing that, we will do, like, we will check our progress. So run a query. So now we will run a query to see how many times the substring rise in appears in Shakespeare's work. To run a query, run the command bqquery. This is the syntax, okay. So escape any quotation marks inside the SQL statement with I mean backslash mark, or use a different quotation mark type than the surrounding marks. Okay. Run the following standard SQL query in Cloud Shell to count the number of times that that the substring rise in appears in all of the Shakespeare's work. Okay. So this is the query which they wanted us to run. Okay. Let's just check this. I will just try to expand this, or else I will just do clear. I guess clear would work here. Yep. Okay. Yep. Now what did we get? The words and the count of those specific words. Okay. Reason. Okay, they have used like, I mean, if a word, so I mean, this percentile symbol indicates like whatever the characters before rising, and also these ending. I mean, percentile will just suggest that whatever the characters or words coming after the this specific word. So here you can say raisin, raisin here, raisins. Okay, that's the reason it has been matched. So that's, so this is the output which we got. Okay, so now in this command, okay, use underscore legacy is equal false. So makes the standard SQL the default query syntax. Okay. The table demonstrates that although the actual word reason doesn't appear, the letters appear in order in several of Shakespeare's works. Okay. So this is, I mean, we can able to check our progress. Let's check. Yep, this is we have done. So if you search for a word that isn't in Shakespeare's work, no results are returned. Run the following search for means Haza returns no matches. Let's check this query. Yep, we got an empty output. Yep. So I think yeah, this is also we have done it. So this is completed. Now create a new table. So now create your own table. Every table is stored inside a data set. A data set is a group of resources such as tables and views. So create a new data set. Use the bqls command to list any existing data sets in your project. Let's check. Okay, no, I don't see anything. So yeah, you will be brought back to the command line since they are since there aren't any datasets in your project yet. Run bqls and BigQuery public data project id to list the datasets in specific project. Okay. ls. Okay, I think this is a public data. Okay, so I think we have got a few datasets. Yep, there with the dataset id. Yeah. Now create a dataset. A dataset name can be up to 1024 characters long and consist of a to z, I mean small letters 0 to 9 and the underscore, but it cannot start with a number or underscore or have spaces. Use the BigQuery mk command to create a new dataset named baby names in your quick labs project. So let's copy this command. Let me just clear this, paste it. So mk, I think it signifies like a make. So now it has created a specific data set under our project. Okay, sample output. Okay, yeah, we got it. Data set has successfully created. Yes, it is done. Now let's check our progress. Yep, good. This is okay. Now run bqls to confirm that the dataset now appears as a part of your project. Okay, bqls. So we are just we, I'm just typing it. Okay. So yeah, previously we didn't get any data set back. So now after we have created this specific data set, now we do have this data set id. Now upload the data set. Okay, before you can build the table, you need to add data set to your project. The custom data file you will use contains approximately 7 MB of data about popular baby names provided by US Social Security Administration. Run this command to add baby names zip file to your project using the URL for the data file. Okay, so using this okay, what does it do? Okay, run this command to add a zip file to your project. Okay, got it. Okay, now I think it is downloading. Mm-hmm. List the file. Let's just do it. Yep, names.zip file. Okay, so now you can see the name of the file added to your project. Now unzip the file. Unzip names.zip. Okay. Okay, now it has unzipped this specific zip file. Okay, that's a pretty big list of text files. List the files again. Okay, cool. The bqload command creates or updates a table and loads data in a single step. Okay, let me just reread it. Okay, the bqload command creates or updates a table and loads data in a single step. You will use the bqload command to load your source file into a new table called names 2010 in the baby names dataset you just created. By default, this runs synchronously and it will take a few seconds to complete. The bqload arguments you will be running are okay. So these are the arguments. Okay, dataset id, table id, source dataset, schema. Okay, create schema in the sense I think this is the information regarding the fields. Okay, it does have name field, gender field and count. Create your table. Okay, let's just copy this. Let me just clear this. Yep, paste it. Okay, bqload. Okay, upload complete. Sample output. Okay, waiting for. Okay, I think we didn't get yes, I think yeah, we got it. Yeah, current set is done. Okay, now yep, let me just check the progress. Yep, it has been completed. Now run bqls and baby names to confirm the table now appears in your dataset. Okay, yes. So when we are listing this baby name dataset, we have a table id, I mean table like names 2010, type is table. because in data sets we might have a type as a view, as I mean as it is mentioned earlier, a data set might contain tables and views. So this is the table which we have created. Yep. So run bq show and your dataset dot table to see the schema. Okay. So okay, we are accessing this table with the help of dataset. Okay. Now we got this schema. Okay, this is a schema and names, gender, and count. Okay, got it. I think okay. Let us read this as well. Okay, by default, when you load data, BigQuery expects UTF-8 encoded data. If you have data that is in ISO 88591 or Latin 1 encoding and are having problems with your loaded data, you can tell BigQuery to treat your data as Latin 1 explicitly using the -e flag. Learn more about character encodings from the introduction to load. Okay, we will look it later. Now we are into task 5, run queries. Okay, now you are ready to query the data and return some interesting results. Run the following command to return the top 5 most popular girls names. Okay, let me just clear. So what it okay, let me just read this out, just check this command. So we are using a bq command tool, I mean BigQuery command tool for querying. Okay, just syntax bqcarry, and this is a SQL syntax. In SQL, what we are doing, we are trying to get the name and count from baby names dot I mean this is the names, this is a table where gender is equals to f, that signifies female, order by count, and descending limit 1. I mean descending in the sense like so descending from big to small, like from alphabetical order, from ISEOA. Okay, sorry, order by count descending. So this is the, I think this is the count descending order. Okay, I mean the value of count, that's the reason it's decreasing. Yep, cool. This we have done. Now run the following command to see the top 5 most unusual boys names. Okay, copied it. Okay, BigQuery, this is the same syntax. We are just extracting name and count from baby names. Okay, dataset, and this is the table where gender is equals to a male. Okay, and order by count ascending. So basically we are going through each male names, and we are just returning the least 5 names, I mean the count, which are having the count values. Cool. Then the minimum count is 5 because the source data omits names with fewer. Okay, that's the reason we, okay, that's the minimum count. Yeah, this is a task. Let's check our progress. Yeah, this is done. Cool. Task is test your understanding. Below are multiple choice questions to reinforce your understanding of these labs concepts. Answer them to the best of your abilities. Okay, you can access BigQuery using I think we have I think this was mentioned up here as well. Let me just show you. So we can access BigQuery using somewhere I have seen, yeah, console web UI command line tool. That's really simple, but yeah. Command line tool, web UI, REST API, I guess. Yep. Which command line tool is used to interact with BigQuery service? This BQ, which we have been using. Cleanup, okay. Run the bqrm command to remove the baby names dataset with -r flag to delete all the tables in the table, sorry, in the dataset. Let's do it. Okay, remove, yep. Okay, this is done. bqrmr, okay. typing y. Okay, check my progress. Yeah, this is done. Click check my progress to verify your performed task. If you have successfully removed Babylon's, you will get assessment. Yep. As you can see, we have got 100 out of 100 in this specific assessment. So now you can use the command line with BigQuery to manipulate data. Okay. So this is just a simple lab, guys. So what we have done, I'll just go through this. I think here you can see like we have examined a table, we have run the help command, and we have run a query against a specific BigQuery table. We have created a new table and queries against that table, and we have test, tested our understanding. Yep. Cool, guys. Yep. So this has been quick. Let me just end this. Okay. Thanks for reviewing. Superb. Next. So yeah, as you can see, we have completed this specific lab session. This is just an introductory, I guess, lab for BigQuery. So we have other lab sessions as well. BigQuery. So there are many categories. Okay. So I will just go through each every lab, and I've tried to post this these videos as well. Yes. Yep. Thanks a lot, guys. Yep. Bye.